Some people say it's overrated.
These were some of the milestone points in his career musically.
He always wanted to be very big in the industry.
The word icon is much overused, but if it applies to anybody in American popular culture, it is Frank Sinatra.
Tonight, on a Vice special report, the groundbreaking treatment that just might lead to a cure for cancer.
I don't have a choice. If I want to live, I need to get this shot.
You're taking things that used to kill us to actually go and kill the cancer.
Yeah. We're going to get cures from the disease. This is going to happen in our lifetimes.
It's okay, Michael. They're just in numbing medicine. Everything is fine. You're doing great.
A little needle stick.
That's okay. That's okay, Michael. That's okay.
All right, we're starting.
Do you feel anything?
Oh, sure, with pressure on something inside.
Yeah, pressure inside your
That's
muscle.
normal.
I think it needs to be out a little bit more, Dr. We're just going through the muscle here. So we are about to drill our burr hole. We've made our incision. We've gone through the skin. We're now down at the bone.
We're then going to inject the virus directly into the brain tumor. This is an experimental procedure. We're going to be using a virus at a particular point in time.
Dr. Pearson, we're going to drill. He might wake up with this.
The next thing is you're going to hear like a drilling noise, okay? Everything is fine.
All right, we're going to drill, Dr. Pearson.
Cancer has affected or will affect almost everyone in the world at some point or another, either through actually contracting the disease or by seeing family members or loved ones suffer through surgeries and difficult therapies. My personal story is no different. My mother was diagnosed with malignant breast cancer around the time we started Vice. In fact, I ran the company out of a cancer ward for months as she received treatment. Shortly thereafter, my stepmother was also diagnosed with breast cancer, and after a long battle and almost constant chemotherapy, eventually succumbed to the disease. Advances in modern medicine have allowed us to live longer and longer, but sadly, cancer to date has remained a constant. In short, it's what kills us. This story is intensely personal and important to me, and the devastating effects cancer has had on all of our lives lead us to bring you this Vice special report. But why are we doing it now? Because today, in real time, there is a revolution happening in the treatment of cancer. And the story is almost too incredible to believe. That A, the diseases that used to kill us en masse, like smallpox, measles, and even HIV, actually hold the key to stopping this disease in its tracks. And B, for the first time in medical history, it appears we just might be on the verge of curing cancer. The story actually begins in my hometown of Ottawa, Canada. We're here at the Centre for Innovative Cancer Research at the Ottawa Hospital, where Dr. John Bell is credited as being the first to figure out that viruses can actually attack cancer cells without harming the healthy cells around them. You're credited with being the guy who figured it out, the guy who had the aha moment, the eureka moment. Can we take a tour around and talk about what you've been doing?
Yeah.
The potential for viruses to eradicate cancers has been suspected for over a century.
In the early, 1900s, people sort of noticed a relationship between virus infections and cancer remissions.
Didn't they inject someone with cervical cancer by mistake with a rabies shot and then...
Yeah, so the rabies is a virus, and they were treating prostitutes who were at risk for rabies because they lived in squalor, and also for cervical cancer because of the sex trade. And they've noticed that their cervical tumors went into remission when they were treated with this rabies vaccine.
Although this phenomenon was documented in Europe as early as 1910, it's only recently that we've learned to manipulate the genetic structure of viruses so that we can use them to treat cancer safely. 5 years ago, Dr. Bell's research took a quantum leap forward.
We did one really nice study, I think, back in 2010. We published about intravenous administration of a virus called vaccinia, which is a smallpox vaccine. And we gave it into the arm of patients, let the virus swim around their bodies, and anytime the virus came in contact with a tumor, it would infect it and start to destroy it. But when it ran into normal tissues, the virus couldn't grow.
This widely used smallpox vaccine was genetically engineered to be safe to the patient by activating only in cancer cells, but never in healthy tissue. Now, once it's in the bloodstream of the patient, the virus acts as a kind of cancer-seeking smart missile by attacking specific proteins that only exist in cancer cells. Its attack on the cancer is a twofold process. When the virus finds cancer, it enters the cell and then effectively turns itself into a virus factory. The virus then continues replicating itself until the cancer cell actually explodes. And secondly, the virus works against cancer's detrimental impact on the body's immune system.
Cancers are diabolical, and they find ways to suppress your immune system. So you actually have a very good immune system that can fight cancer at all times, but it finds ways to get around that. It secretes hormones that suppress the immune system.
The virus deactivates the cancer's cloaking mechanism and actually alerts the body's immune system to the tumor cells. The patient's own immune system then takes over and eradicates the exploded cancer cell.
You're a researcher, you're a scientist. How excited are you and how excited is the community about these, what we believe to be groundbreaking
I love coming to work every day anyhow, but these are really revolutionary treatments which no one has seen before. I feel confident saying to people now, things are going to be different. We're going to actually treat people. They're going to get cures from their disease. This is going to happen in our lifetimes.
Yes, you heard that right. What he's talking about is not necessarily a treatment, but perhaps a cure. Using viruses to actually fight cancer is a rapidly developing field that has begun to show some seemingly miraculous results. Thanks to recent scientific breakthroughs, the infectious agents that have killed us for thousands of years are now actually being used to save lives. Here at the renowned Mayo Clinic in Rochester, Minnesota, doctors are fighting myeloma, or bone marrow cancer, with a virus that in the past has killed over 200 million people. It was developed by a team led by Dr. Stephen Russell.
So what virus are you using to fight cancer?
Well, the virus we're using actually originated in the throat of a boy called David Edmonston, who in 1954 had a measles infection. And we added a new gene into the virus in order to make it better for treating cancer.
The engineered measles virus is produced in a specially designed secure laboratory at the Mayo Clinic, which for the first time has allowed cameras to document the progress that they're having in the treatment of bone cancers.
This is a wave bioreactor. So in here are cells being grown in culture medium, and
Human cells.
these are human cells, the cancer cells. They are then infected with measles virus. And the measles virus gets into the cells, and the cells then start making more and more copies of the measles virus. And at the appropriate time, we harvest everything and we isolate the virus from the mix. And that's the product that we're going to administer to patients.
For many patients, measles therapy is their last hope. Troy Sproul was diagnosed with multiple myeloma in 2012.
When I was told how aggressive that it was, I was like, well, let's just do what has to be done. Now seeing over 2 years that nothing's worked for me puts you in a dire situation.
2 states over in Minnesota, Daniel Odegaard was diagnosed with multiple myeloma 5 years ago.
The cancer itself is mostly fatigue and bone pain. Your bones become so brittle and thin that they break very easily. So that can be very painful. And then people die from it. So you particularly look in the chat rooms, and there are several people every week that are dying from it.
Killing more than half the people diagnosed in less than 5 years, myeloma is an extremely aggressive cancer.
I want to live, and I want to live for myself and for my family.
I know that you are battling over it and you are overcoming it.
Still fighting and battling, and we're going to do what Superman would do, right?
Yep.
We're going to win.
Mm-hmm.
All right. Love you, buddy.
Yep. We do.
Troy and Daniel are among a small group of patients that were selected from more than 1,000 candidates for the second phase of the trial of measles therapy.
Done about 8 different regimens of chemo. Nothing that I have been on have worked for me.
These 2 camera heads will just come in and slowly rotate around you.
I have had about 7 different strains of treatment now, different drugs. After 2 or 3 months, each one of them has stopped working. I also had 2 stem cell transplants. In both of those cases, the cancer started being very aggressive again.
The patients in this trial have exhausted all other standard treatment options.
The best thing for me at this point was beginning to seem to just get off of chemotherapy altogether and basically get it over with and let yourself die.
I don't have a choice. If I want to live, I need to get this shot.
The next day, Troy and Daniel are infused with the measles virus.
It's here.
Here it is.
Is that grossing you out a little bit?
Me?
Yeah.
Oh, heck no.
Oh, okay.
I've had so many of these, it doesn't really bother me at all.
We have checked this to be the measles virus.
Blood pressure is 148 over 84, and your pulse is 56.
Vitals here. So we are beginning 10:02.
The infusion contains the equivalent of 10 million doses of the measles vaccine.
It's going.
Mama.
This is what we wanted. This is gonna work.
You better.
We've gone through a lot of treatment. This offers the hope of being in remission without any more chemotherapy. We know it's not guaranteed, but we know it's possible. And to take those moments and know that we might have more time. We'll have time with our kids and our new grandbaby. You know, it's like scary. But that's what this is offering us. It's that hope. It's a big deal.
This is a big thing. You know, not just living for myself, but you know, what I have at home relying on me.
To understand what the virus is actually doing inside the bodies of Troy and Daniel, Dr. Russell showed us the remarkable evidence of the virus actually targeting cancer cells that they found during the initial phase 1 trial.
We have a gene in the virus that traps radioactive iodine in cells where the virus is growing. So now, if we look at what happened with the radioiodine scans, this is before treatment. This is day 8 after treatment, and there's dramatic uptake of radioactive iodine. But you know, what this tells you is that that virus in the bloodstream targeted the cancer. And if you look at the PET scan of the entire lower half of the body, you can see a lot of very big tumors on the glucose uptake scan. And then if you look at the radioactive iodine scan on day 8, you see that they correlate, that the virus has actually gone where the tumor is.
Wow. A week after the infusion, Troy and Daniel returned to the hospital to be examined.
Can we stop and get your height and weight a little
Sure.
bit? About 152. Perfect. 182.3.
You're on day 8?
Yes.
And generally for the first week it's pretty rough.
It was rough.
Yeah.
And now I think I'm past it as of yesterday.
You're feeling better now?
Oh yeah, big difference.
Really?
Oh yeah.
That's good.
Yeah. I'm ready to race one of the cameramen down the hallway
This past week has actually been pretty hard.
Right.
And they anticipate that you don't get better necessarily right away.
Right.
And a lot of very severe bone pain, a lot of nausea, throwing up, a lot of fatigue. The pain tends to go where the cancer is the most prominent.
Right.
And evidently it is actually because that's where it goes.
That's where they're fighting it.
That's where they're fighting it.
Yeah. Although Daniel and Troy won't know for some time if the treatment has worked, they are optimistic because of the astonishing success of one of the patients in the first phase trial. The amazing response of Stacy Erholtz to this therapy is what everyone in phase 2 of the trial is hoping for.
Stacy's like in a total remission, no cancer to be found. All her tumors have shrank. From what I understand, they're gone. I mean, I'm hoping for them to come back and tell us that I'm cancer-free.
Yeah.
I'll do a backflip in front of you.
We had the chance to talk to Stacy, whose recovery, it seems, is nothing short of miraculous.
Well, I was just about to turn 40, and it wasn't but maybe 6 months later that I was diagnosed with multiple myeloma.
Over the last 10 years, Stacy took every available myeloma treatment without achieving a lasting result.
There were no more approved drugs that I could take. Nothing.
At this point, the myeloma had spread throughout her body.
I had it disseminated, but I also had a tumor the size of a golf ball right here in my forehead. My daughter Eleanor and my son Oliver named him Evan.
This is Evan.
So it was a huge tumor the size of a golf ball, looks like.
Yeah, it's pretty big. And you can see it's not only a big protrusion, but it's also destroyed the bone.
It's sort of eaten away. After just a single injection of the measles virus, Stacy had a profound reaction.
What happened is the most incredible headache. I can't even put to words. It felt like my head was going to blow off. And then it was a couple hours later that I was shaking and trembling and I was in full-blown rigor and temperature of 105. I think it was just the measles storm in the door and it was just intense is kind of what I think it was. 36 hours after the measles infusion, Evan disappeared. Just kind of ate him up, killed him off.
That's before therapy. This is 7 weeks post-therapy.
Wow.
And what you can see is the brain contour has come back to normal, the skin contour has come back to normal, and all of the tumors went the same way.
Every day, I had more and more energy, an energy level that I had not felt for so many years. I've had 18 months of remission. I absolutely believe it's a game changer. Absolutely.
Now, this was the first time in history that a virus was documented to completely eradicate cancer that had disseminated throughout the body.
It was a beautiful demonstration that a virus given into the bloodstream can really target sites where the tumor is.
It loves to beat up on cancer.
It loves to beat up on cancer, yeah. Very well put.
Now, these incredible results are not just limited to the Mayo Clinic. We got another first look at a phase 1 trial that's using this kind of viral technology at the MD Anderson Cancer Center in Houston, Texas. Professor Juan Fueyo is the director of the Brain Tumor Research Program.
We are working with the virus that produces the code and trying to make it to kill cancer cells.
Yeah.
So it's the virus that came in from the code.
Like the spy that came in from the code, sure. The researchers genetically modified the adenovirus that causes the common cold so that it would attack brain tumors. One of Professor Fueyo's key partners in bringing the virus technology from the research lab to the actual clinical trials is renowned neurosurgeon Dr. Frederick Lang. What does putting it into practice mean?
The first step is to take that virus, the laboratory virus, and then test it in animal models that
like
mimic
rats or
yes. We actually use human brain tumor models that we get from patients and we grow them in culture.
So hold on, you get actual brain tumors from humans.
Right.
And then
we bring them to the lab.
Right.
And we actually are able to culture some of the cells from those brain tumors. And we can put those into mouse brains and then we can test anything we want against them.
Dr. Lang then showed us what they found out when they tested the modified cold virus, then called Delta 24, on mice.
Each of these is a single animal.
Right, and those are tumors?
We have tumors that we can shine a camera from the outside
and you can see the tumor lighting up. These animals we injected basically saline, and you can see that with time, the tumor's actually getting bigger and bigger.
Right.
Like this guy here is like really growing out of control, and that's only in 3 weeks.
Right.
Okay. On this side is where we gave the Delta 24.
Right.
So at the start, you can see they all have large tumors. Like, look at this guy, he's a huge tumor. So then follow him down, you don't see anything.
Gone.
The tumor's gone.
This proves that the virus is successful in attacking the tumors.
Right.
Now we've got to get the virus there the most efficient way possible.
Exactly. That's what we do in the operating room.
Right. And can we go to the operating room and see what you do there?
We can go to, and we'll see a patient who's getting a viral injection.
Okay.
William Michael Connor.
In May of 2014, Mike Connor was diagnosed with glioblastoma. Within days, he underwent surgery to remove the tumor, and that was just the beginning.
I had 30 radiation treatments over a 44-day period, and I had 44 days of chemotherapy.
Despite intensive treatment, the prognosis is bleak.
With glioblastomas, there are some people that survive for some period of time. Most don't make it a year, by far.
How are you doing since I last saw
I've been fine.
No
Everything's
issues?
been good. I haven't had any problems, haven't had a headache or anything.
No
at all.
seizures or anything?
No, nothing.
So let me just show you your films.
Right.
Here's the tumor here, sort of just behind your eye. You see that there's this enhancing mass. Let's now go into what we're going to do.
Right.
So we're giving you 3 times 10 to the 10th viral particles. So a lot of viral particles injected into your brain. And this is an adenovirus, so it's a common cold virus.
Right.
Okay. The other big thing is we don't know if this is going to work.
Right.
Right. Now, in our first trial, we injected tumors like this in 25 people. Okay. And 3 of them, the tumor went away.
Right.
But that means that the other ones, right, the other 22, it didn't completely go away. And I don't know how you're going to respond to this.
I'm number 4. I don't know what's going to happen. I certainly want to be a father and a husband for quite some time to go. So I'm very, very pleased to be able to go into this tomorrow.
Now, unlike the measles infusion, in this case the virus is actually injected straight into the tumor. It's a multi-stage process that will take up to 5 hours to complete.
Okay, ready to go?
I'm ready to go.
All right, I'm just going to put some iodine here. Little needle.
Yeah.
And then it burns a little. We're now going to put this on there.
This frame will allow Dr. Lang and his team to locate Mike's brain tumor with pinpoint accuracy.
Just going to make sure this fits. Hold your head stiff so I can see if I can move it. You're good. Those images are now sent up to the stealth station, and then we can now manipulate them in 3 dimensions up in the operating room. This is Mr. Connor. We're operating on the right side of his head. Our images are up. That's his films. We went along that trajectory. We'd be in it the entire way, so if we set that as our target.
Dr. Lang and his team now calculate the coordinates for the path they will take through Mike's brain.
That's going to be our entry point. I think that's perfect.
So we're outside the OR right now. Can you please tell us what's going to happen?
Right, so we're going to do what's called a stereotactic biopsy.
Right.
A biopsy means we're going to take a piece of the tissue from the brain tumor, and we're going to prove that what we're seeing on our MRI scan is actually a recurrent brain tumor.
Right.
Once we've proven that, we're then going to inject the virus directly into the brain tumor. Okay, guys, I want to just tell everyone that this is an experimental procedure. We're going to be using a virus at a particular point in time, and when we do the Delta 24, we have masks that everyone has to put on. So this is an arc quadrant. It's created so that the center of this ring will hit the target. It's secured, and it's flat.
Finally, after 3 hours of preparation, the surgery begins.
It's okay, Michael. That's just the numbing medicine. Everything is fine. You're doing
Just
great.
a little needle stick.
Yeah, that's okay. Okay, Michael.
Mike will be conscious throughout the operation so that the doctors can communicate with him.
If you need anything, just ask for it, okay?
So we're making our incision.
Do you feel anything? Any pain?
I can feel
Just a little touch.
Feel us touching you?
You can give you another 0.5 of midazolam.
Okay, so we've made our incision. We've gone through the skin. We're now down at the bone.
The next thing is you're going to hear some noises there, like a drilling noise, okay? All right, everything is fine.
All right, we're going to drill that too. Thank you. Irrigation. So I see the brain now. 160 plus 100 plus 20 is 190. Let's go ahead and do our biopsy at 190. But we're going to get the tissue now to see if we are actually in tumor. Let's hope we get a nice piece here. Great, so we got a nice core here.
Dr. Lang removes 4 cores from different parts of the tumor. He then scrubs out and heads to the pathology lab to examine the cells he's just taken from Mike's brain.
These blue spots on the screen are all cell nuclei, and there are many more than normal. We see these vessels that are abnormally thickened, so we know that that's tumor.
So once we figured out, okay, this is a cancerous tumor, what next?
So now that we've documented that he has a recurrent glioblastoma, we're going to go back to the operating room and inject the virus.
All right, everyone, we're going to get ready to inject the virus, so everyone should get their masks on. This is the virus in the vial. We're just going to draw this up. In this virus is 30 billion viral particles per ml. We're going to inject 0.1 every minute.
Okay, Michael?
Okay.
Everything is fine. Dr. Lang is injecting right now, okay? Doing great.
You okay?
Yeah, we're fine.
Now, Mike is just one of the many people in the world diagnosed with malignant brain tumors every year. But he's in the tiny minority with access to this revolutionary treatment. Frank Tufaro is a former microbiology professor and the CEO of a company that is trying to change this limited access and bring the MD Anderson therapy to the wider public.
We could bring this treatment to market, we feel, in 2 years. We've worked very closely with the FDA. In fact, we have what's called fast track designation for our drug because the FDA realized that this looks like a promising technology.
So once we are done, we'll take you upstairs to the intensive care unit. Then we'll just watch you there for 1 day.
We already use viruses for vaccines, polio vaccines. These are all live viruses. We've been giving it to people for years. Now we're looking to use it in the cancer setting. I think it's going to become a main driver of cancer therapy in the next 5 years.
6 weeks after his surgery, Mike's brain scan shows his tumor has stopped growing.
In looking at the latest MRI, we're seeing improvement, which is very, very exciting. I feel extremely lucky with the treatment and the way things are going for me. I love you.
Now, it's important to remember that this treatment at MD Anderson and the measles therapy at the Mayo Clinic are both in the early stages of testing. What we are showing you are the first reports of ongoing trials, and as such, the success rates will vary. However, there is one radical new therapy that has proved consistently effective over sustained clinical trials, and it's based on a particularly insidious pathogen that has inspired dread for more than 30 years. Perhaps the most terrifying virus of the modern era has been HIV, the virus that causes AIDS. If, like me, you grew up in the 1980s, it was difficult not to be affected by the pandemic that this virus caused. So much was unclear about this disease, from its origins to its effects, and even its detection and treatment. For a long time, AIDS was synonymous with fear, which is precisely the reason why the news that this deadly virus is offering perhaps the best chance of all in finding a cure was so surprising. Here at the Children's Hospital of Philadelphia, doctors are using HIV to treat leukemia.
She was diagnosed just after her 5th birthday. They kept saying that she seemed a little more sick than most kids are and nauseous all the time.
For 5-year-old Emily Whitehead, acute lymphoblastic leukemia proved to be unexpectedly aggressive. In 2012, after 2 years of chemotherapy, she relapsed for the second time.
She went from 85 to 90% chance, to less than 30% chance of survival.
It seemed that there was nothing that could help Emily.
So the doctor told us that we were pretty much at the end and talked to us about taking her home. And we weren't ready to give up at that point. And so we called Children's Hospital of Philadelphia just to say, do you have any type of a clinical trial? We're at the end and we need something. And they said, well, actually, the T-cell therapy has just opened and we're accepting our first patient.
T-cell therapy is the brainchild of Dr. Carl June, whose background in studying both cancer and HIV, the virus that causes AIDS, gave him a new perspective to an old problem.
All the standard people trained in oncology went in with other oncologists, and they didn't know about the potential really of HIV to apply that to cancer.
Now, the key to this concept is the manipulation of the patient's own T cells, the very foundation of the human immune system. They're white blood cells that circulate throughout our bodies, seeking out and destroying foreign pathogens.
So what we learned was how to use HIV to reprogram that T cell so that then it can easily tell if it's a leukemia cell or a normal cell. You know, we have in planes IFF, identification friend or foe.
Sure.
And we use that in the military to know when you see, do you shoot or not? Is it one of your own? This is IFF for the T cell. The T cell wakes up and it says that's foe and it says kill it.
Now, Emily's parents were utterly desperate, but the idea of a treatment based on HIV was still troubling to them.
We were overwhelmed with fear. Anyway, before we heard any of that, the doctors said, you know, I can't tell you that this treatment will take Emily's cancer away, but I can tell you that she can't get HIV from this treatment.
There are a number of labs over 15 years learned how to, if you will, gut HIV. And then what's left behind is a machinery so that it can infect a cell, but only once. And when it does that, it doesn't cause disease, but it inserts the reprogramming element that we want.
Although Emily was the first pediatric case to receive the treatment, 3 adults had already undergone T-cell therapy. In all of those cases, it was found that once the T-cell began to attack the cancer, that the patient's physical reaction was extreme.
The first patient was treated in July of 2010, and he became very ill after we treated the patient, and to one point where last rites were given, and 2 or 3 days after we treated him, he had 104-degree fever, and that lasted for about 3 weeks.
And it turns out that with Emily's treatment, the reaction was even worse.
The same thing happened as it happened in adults, but it was actually more vigorous and more violent. She went to 106-degree fevers. It was really touch and go.
You know, she spent 14 days in a coma. Because it overwhelmed her system. It was absolutely brutal to watch. The doctors said, call your family in because there's a 1 in 1,000 chance she was going to be here in the morning. Emily just kept fighting. She, you know, woke up on her 7th birthday when she was coming out of it.
Thankfully, Emily survived the infusion. But because she was the first pediatric patient, nobody actually knew if the therapy itself would be successful. But Dr. June hoped that her type of pediatric cancer was similar enough to get the same incredible results that they had seen in the first adult patients.
28 daase after we treated him, they finally did a bone marrow examination, because bone marrow is where the tumor is in leukemia. And it came back there wasn't any. We all thought that was a great result, but I was really incredulous. I said, this can't be right. You know, can you do it again and look on the other side? And so I looked at the other hip, and the same thing came back on day 31. There was no leukemia.
April 17th, 18th, and 19th is when they put the cells in. May 10th is when I got the call from Dr. Grupp. Can't find a cancer cell.
They gave it to her, and 4 weeks later, she was in remission.
What do we tell them about the T cells?
That they went to boot camp.
They went to boot camp. Your T cells went to boot camp. What did they learn at boot camp?
How to kill cancer.
They're like, you know, getting dogs ready to go eat that cancer. Emily was the 4th patient in the trial, and all 4 patients went into remission within 4 weeks.
We had seen an unprecedented thing where pounds of leukemia literally went away in a few weeks.
When you say pounds of leukemia, you mean someone loses 5 pounds, let's say, and that's leukemia that they're losing?
Yeah. We did calculations on our patients, and they had between 3 and 7.5 pounds of tumor when we treated them. And so that's the power of this approach.
Amazing.
Is that better? All right. How you feel?
Good.
You go to school?
Yeah.
Every day?
Yeah.
Ever miss?
Just to come down?
just when it's my fault. Anything bothering you?
No.
Now, if you didn't know that she was sick, you can't tell
You
that.
would never know.
Yeah.
She's just a normal, healthy.
So we've had full remission.
Absolutely.
Yes.
Yeah.
How does that make you feel as a doctor when you come up with this thing and say, well, we've tested it, we've tried it, and then you see a young girl who was dying. She was done, and now she's cancer-free. I mean, that must be the greatest
an
feeling in the
incredible
world.
feeling.
Yeah.
The reward of seeing that, both from the parents and the children, is you can't describe it.
Now, one thing that Dr. June hadn't expected was that despite astonishing results in his early patients, that no one would fund the rest of his trial.
The reason our philanthropic funding dried up was we had the 2008-9 Wall Street collapse.
Right.
And therefore, a lot of the money that went to the Leukemia and Lymphoma Society and so on, that was just dried up.
Yeah.
And we couldn't get money from the government, and even to this day, we're under sequestration.
In desperation, Dr. June took an unorthodox step.
Normally, you can't publish your results when you have 1, 2, or 3 patients.
Right. In the hope of spurring interest in the research, he released his groundbreaking results.
The first patient was on the front page of the New York Times.
Right.
And our lives completely changed that day.
When we read this and we heard about Emily doing so well, and it was just so hopeful to think there was another way to go about battling this without putting your kids through such torture.
Troy Lee was diagnosed with leukemia at the age of 5. She underwent 4 years of chemo and radiation before becoming the 10th patient in the trial.
Within a month, I'd say, she was back in school.
Wow. How long have you been in remission now?
A year?
A year.
A year and 9 months, right?
A year and 9 months, nearly 2 years.
Yeah.
She's able to play with her friends and have sleepovers like a normal 11-year-old girl does.
Watching her for so many years struggle is agonizing for a parent, and
Sure.
looking at her now, it's really incredible.
So how you feeling?
Good.
Any problems?
No.
Not been in the hospital for any reason?
No.
You're just perfect in every way?
No.
No? Okay. So no complaints though?
But here's the real headline. 39 children have since been treated with Dr. June's T-cell therapy, and an astonishing 90% of them have experienced complete remission.
So nothing hurt? Certainly speaking for myself, and I've been at this for a while, I've never seen anything like this in my life.
These patients, when they enter remission, most stay in remission for several years. There has been no therapy that does that.
Now, while I was interviewing Dr. June, I realized that we were no longer talking about treatment, but that we were actually talking about a cure, which in my mind immediately raised 2 questions. So everybody watching this is going to be saying, oh my God, okay, how does this get out from UPenn to the rest of the world?
It's probably going to be out, FDA approved and available throughout the United States in 2016.
And my second question was, will this work for other cancers? What about other kinds of cancers? I know it's early days, but theoretically, what are we looking at?
There are about 300 kinds of cancer, and there are about 5 kinds at least of leukemia, and so many of those, I think, are going to be cured.
And that's why all these doctors are so excited.
I think you're going to see people having great responses where they leave the clinic and their cancer is gone. And I think that is happening already, and we're going to see more of that.
We know we're on the right path, and it's really energizing to keep us pushing in that direction.
So this is probably the biggest news in cancer since chemo and radiation.
This is one of those things, it's a true paradigm shift, in this case for cancer.
You're taking things that used to kill us to actually go and kill the cancer.
Yep.
Now, if these response rates can be held to a wider population, and viruses can be engineered to attack other cancers, then we have truly reached, in Dr. June's words, a paradigm shift in treating cancer. And for all the Emily Whiteheads out there, this is certainly fantastic news. I hear you like basketball. Who's your team? You like the 76ers or?
Penn State.
Penn State. Yeah. Oh, college. Are you going to go to Penn State for college? Yes. Do you have anything you want to say to anybody out there who's fighting cancer?
Keep fighting and believe in yourself.
Okay.
reality is punishable by death.
On the next episode of Vice, the future of recreational drugs.
At the end of the day, you've got to realise that in the pharmaceutical industry, things are tested on animals. These things here are probably going to be tested by somebody's children.
Then, the reality of sex change surgery in Iran.
The vast majority of cases are not true transsexuals. I can easily say 25% are asking for this injury because they are trying to get social acceptance.
It's an all-new episode of Vice.
You're just too good to be true.
They asked her what was the high point.
Can't take my eyes off of you.
For 4 guys under a street lamp. First time we made that sound.
Frankie, this is your time.
Our sound. That was the best.
Ladies and gentlemen, the more season. Can't take my eyes off of you.
Ladies and gentlemen, Frank Sinatra.
These were some of the milestone points in his career musically.
He always wanted to be very big in the industry.
The word icon is much overused, but if it applies to anybody in American popular culture, it is Frank Sinatra.
Lannister, Baratheon, Stark, Tyrell, they're all just spokes on a wheel. This one's on top, then that one's on top, and on it spins. I'm not going to stop the wheel. I'm going to break the wheel.
We can learn to live with the wildlings. We can add them to the army of the dead.
I am a queen, not a butcher.
All brutes are the butchers of meat.
I need to show that I'm a fierce she-wolf.
Do you still want to help your crap?
Yeah, I still need you to do that.
If the president and I, we're like this. Not scale.
I'm used to dealing with angry, dysfunctional men, i.e. men.
You're the president of the United States, man. What you say goes. You're like a real-life Mariah Carey.
Now it's the president's turn. He met? Yeah, I'm the president.
I just got humiliated by a fucking teenager. All I care about is Nucleus is better than Pied Piper.
You need serious funding to go up against Nucleus.
I want to back you.
Brand awareness. We're getting Pied Piper out there.
Synergy, bitches. Know what that means?
Does it mean taking a stack of cash and lighting it on fire?
Crazy fucker, I love this guy. This is war. If there's any greatness in any of you at all, now is the time to access it, please.
Maybe start after lunch? Lori, you can sit down if you want to. Do you want to? I'm standing, but you don't have to.